All right, today we're looking at chapter 1.9, describing location in a distribution. So first we're looking at frequency tables. We have seen these before. They can include columns which show just a frequency or relative frequency. And then today we're going to show how you can show a column for cumulative frequency and cumulative relative frequency as well. So as we've already seen, we know that frequency means counts. Relative frequency, we're taking those counts and showing them in a proportional relationship. So expressing those parts of a whole in terms of a fraction, decimal, or percent. If we use the language of cumulative, we're looking at an accumulation or sum of the frequencies up to and including that event. So we think of this as a running total. Okay, we can also look at a cumulative relative frequency, an accumulation or sum of the relative frequencies up to and including that event. So we can think of cumulative for just frequency or cumulative relative frequency when we're looking at it as a proportion instead. So here's a good example. So here in example 1, we're looking at a hardware store that maintains that packets contain 60 nails. To test this, a quality control inspector tested 100 packets. So our N value is 100, right? We're testing 100 packets. And we found the following distribution. We want to find all of those measures of center, the mean, the median, and the mode. So we start off by looking at our data in our L1. So L1 right here, this is all the outcomes that play out. So in all those different packets, these are the number of nails that showed up. We had 56, 57, all the way up to 63. And we're seeing all of the frequencies or counts that go with each of these particular outcomes. So for example, there were 8 packets that contained 56 nails. So now the L2, we're going to type in all of these frequencies, all of these counts. All right, so let's look at our graphing calculators. I'm going to hit Stat, Edit, and I'm going to type in my data in my list 1. Always take a moment and double check. It's easy to type something in wrong. Okay, that looks good. Now in the L2, here I'm looking at the counts that go with each of those outcomes. All right, so again, take a moment, skim through it. Make sure that you typed in everything correctly. So we have our data in our L1, right? All of the options that could have played out, and then the frequencies that go with each of those outcomes. All right, now in the L3, we want to look at the cumulative sum. So our running total up to each of those particular outcomes. So here I'm going to say in my L3, what I want is the cumulative sum of everything in my L2. Let me show you the keystroke for that right here. So to get there, we're going to do second stat, go over to ops, our operations, and then we're picking our 6th choice, which is cumulative sum. And we're saying we want that running total of our L2. Okay, so here I go. So I'm up in my L3. I have to be at the tippy top. That has to be nice and dark. And I'm going to say second stat. Go over to ops, my operations. And it's my 6th choice right there, cumulative sum. So I hit enter. And I tell it I want the running total of my L2, second 2. There's my L2. I can see the keystrokes right there. I hit enter. So here again, it's showing me a running total at each stage. So let me write that in and then talk you through that. So here I see 8, 19, 33, 51, 72, 80, 92, and that should be 100 right there. Good. Okay, so what that's telling me is, well, you have 8 data points, 8 packets that contained 56 nails. You have 19 packets that contain 57 nails or less. We have 33 packets that contain 58 nails or less. It also helps me see the position. So if I wrote this all out as raw data, I have 56 data points, or I'm sorry, I have 8 data points that are all 56. So position 1 through 8 would be data points 56. Okay, and then 9 through 19, position 9 through 19 would have values of 57. Positions 20 through 33 would have values of 58. Okay, and then lastly, I want my cumulative relative frequency. So I want to see my running total as a proportion instead. So in my L4, I'm going to say, look at what's in my L3 and divide it by my N number. How much data do I have? I have 100 packets, so I'm going to divide that by 100. So again, right here, this is looking at my total divided by N, right? That's just how much data I have. So if I slide over to my L4, right, I'm saying look at what's in the L3 divided by N. N is 100. So I hit enter and that column fills up. So let me transfer that onto my paper. So 0.08, 0.19, 0.33, 0.51, 0.72, 0.8, 0.92, and here that should be 1, right? Because that's just saying 100% of my data showed that packets had 63 nails or less. Okay, so now I want to find my mean. So to find my mean, I can use one more column. So let's say I look at the L5. So in my L5, I'm going to look at the product of each of these particular outcomes. So everything in my L1. And I'm going to multiply that by my frequency right here that's in my L2. So essentially what I'm doing is I'm taking here the product of the number of nails per packet and the frequency of each of those particular outcomes. So let me go to the top here, my L5 right here, and I'm saying L1 times L2. So that column fills up. I see 448, I see 627, 812, 1,062, 1,260, 488, 744, and 504. Okay, this is helping me to get to what my mean is, because I'm seeing that I had 8 packets with 56 nails, 11 packets with 57 nails, 14 packets with 58. So we're really just multiplying each of those, and then we need to add them up. So here I'm going to need the sum of that list. So my mean over here, if I just write this out, my mean is really the sum of those products, each outcome, multiplied by its frequency, and we're going to divide it by the total frequency. So the sum of our frequency, whatever n is, how much data do we have, right? That's going to get us our average. So to get to the sum of that L5, right, we've done this before, we do second stat over to math. It is our 5th choice, and we're saying sum of the L5. So the sum of all of that is 5,945. Okay, so I'm taking that 5,945, dividing it by n, right, 100, and that works out pretty easy, 59.45. So the average amount of nails per packet is 59.45. Let me slide that up a little bit and fill that in right here. All right, next thing that I want is the median. So I need to figure out what is the position of the median. I have 100 data points, so add 1, divide by 2. So 101 divided by 2 would be 50.5, right? So I'm thinking of that as a position, and that's not a position. I know that that really means that I need to find the average of what's in the 50th position and the 51st position. So remember that that cumulative frequency is helping me to see that. So position 1 through 8 would be a data point of 56. 9 through 19 would be 57. 20 through 33 would be 58. 34 through 51 would be 59. So position 50 and position 51 are both 59s. So if I average those two 59s, I'm still at 59. My median is 59. Okay, my mode, which one is occurring most frequently, right? What am I seeing as the highest frequency? I'm seeing right here 21. 21 packets contained 60 nails. So the mode, what's most common, let me add that here, mode, most common, ends up being 60. All right, then there we go. Let's say that I wanted to check this. I can double check. I can double check the mean, for example. So if I did one var stats, right, this is how we get it shorthand. So stat, calc, one variable statistics right here. I can say, well, I want to look at my L1 as my list. My frequency is my L2. So here I could say L1, comma, L2. And here it's confirming right there that it's 59.45 as the mean. Okay, now on the fancier calculators, it will guide you through that. It will say list, you say L1, frequency is L2. And I'm really just doing that to double check it. I still want to make sure that we understand the mechanics of how we do it longhand first. All right, next up here, when information has been gathered in classes, so grouped data, we use the midpoint of the class to represent all values within that interval. We assume, now this is really important, we assume that values within each class are distributed evenly through each interval. So here we're given a bunch of data on that represents scores on a 25-point quiz, and we want to find the approximate mean, only the mean here, not the other measures of center. So here we're not given the raw data. We don't know what the actual scores are. We're presented it as an interval. So anything that was a score of 1 through 5, we saw 7 of them. Any score that was a 6 through 10, we saw 12 of them, and so forth. So what we're going to do here is we're going to say, well, can we find the midpoint of each of these intervals? That will be the placeholder for each score. So we're saying, let's make the L1 right here essentially our data placeholder. It's going to represent all of these scores. So if I average 1 and 5, it ends up being 3, right? I'm just looking at the midpoint. What's right smack in the middle? If I average 6 and 10, I get 8. 11 and 15, I get 13. 16 through 20, 18. 21 through 25, I get 23. Okay, so again, we're saying we're assuming that the values within each of these classes, each interval, is evenly distributed. So we're just saying, let's use a placeholder. Whatever number's right smack in the middle, the average of those two bookends, right? That's our midpoint. That's our data placeholder. Okay. L2 is our frequency. So again, that's our counts, right? The amount of scores that fall within each spread of values here. And then in the L3, we're going to multiply those two just like we did before. So the process is very similar. Okay. What we do need to know, though, is how much data we have. So if I add up this column, I'm going to see that my sum is 55. So my n value here, n, is 55. We have 55 data points, 55 scores from this 25-point quiz. So I'm going to go ahead, I'm going to type that data in. I just need to clear up my lists. Okay, L1, this is like our data. In the previous example, it was the number of nails, and here it's the midpoint of each of these classes, these intervals of scores. So 3, 8, 13, 18, 23. Okay, the frequency for each of those, 7, 12, 15, 10, 11. We're good to go. We slide over one list and we say, let's find the product. So L1 times L2, enter, that column fills up. So if I quickly fill that out, right, I see a 21, 96, 195, 180, 253. Okay, and then my process is really the same. I'm going to need the sum of these products. And then to get my mean overall, I'm just looking at the sum of those products divided by the sum of the frequency. How much total data do we have? What's the n value? So if I go home now, I go second stat over to math. I want the sum of my L3. So 745 right here. Okay, so I take my 745, I divide by 55, right? That's how much data I have, my n value, and I'm going to get this approximation of 13.55. So my approximate mean is 13.55. I can't give it as something exact because I wasn't given the raw data. I was only given classes, spreads of values for each of these scores. So this is the best approximation we're going to get using that midpoint as our placeholder. All right, flip the page over. Let's look at the back side. So here is just an introduction to percentiles and percentile ranks. So percentiles are most often used for determining the relative standing of an individual in a population or the rank position of that individual. It tells us the percent of the total frequency that's scored at or below that measure. So a percentile rank is the percentage of scores that fall at or below a given score. So let's say that you earn a score on the SAT that puts you in the 80th percentile. Right? That means that 80% of students who took the same SAT as you earned a score at or below your score. You outperformed about 80% of your peers. Okay, here I'm just giving you a little bit more information that I'd like you to read through when you have more time, right? But essentially it's what I just said. So when we're thinking of a percentile, we're saying that if you score in the 80th percentile, about 80% of your peers had a score at or below your score. You outperformed about 80% of your peers. Okay, one thing just to note though is that if we end up with a decimal, we do round to the nearest whole percent. So if we end up with something like 74.5%, that goes to 75% or the 75th percentile. Okay, so here if we're calculating a percentile rank, what we're looking at is we're looking at here the number of scores that are below our score of interest, plus half of those that are equal to our score of interest, divided by our total amount of data, our total amount of scores. And then to make it a percentage, we just multiply by 100, or we slide our decimal 2 units to the right. Okay, so here looking at example 1, A student's score on the ACT is at the 94th percentile. What does that mean? So that's similar to what I was just saying. We're saying that 94% of students who took the ACT earned a score that is at or below this student's score. Right? We could say that this student outperformed about 94% of other students. I'll add in who took the ACT. Okay, so when we're saying that something is in a certain percentile, the 94th percentile, 94% of students who took the ACT earned a score at or below this student's score. This student outperformed about 94% of other students who took the ACT. Okay, example 2 here, we actually don't have to solve anything because of language that we're given. So we're told that we have 29 students in Sue's government class. She earned the median score. What is her percentile rank? So we should know that the median is really the Q2, the second quartile. So we should end up with the 50th percentile. Let's say that I wanted to double check that, right? If I'm thinking of what Sue's position is, if she's the median, I know that 29 plus 1 divided by 2, 30 divided by 2 would put her in the 15th position. So if I check this with the formula, I know that 14 students were below her, plus half of the 1 Sue. Divide that by 29 students in the class. So here I'm going to get 14.5, right? I'll just double check. 14 plus half of 1, right? There's my 14.5. Divide that by 29 students in the class. There's my 0.5, right? Multiply that by 100, right? 0.5 is going to get me 50th percentile, right? Because that just makes 50%. So 50th percentile if we're calling something the median. I didn't even need to calculate it. I just wanted to double check. Okay, example 3, here we're given actual data. So we're looking at scores on an English test. Let me just slide that up. And I'm saying find the percentile rank for a score of 86. So here's my 86. So I want to count up how many scores are less than 86. I put them in order. So here, let's see how many scores did I give you total. There's 20 scores total. So our N is 20. So if I count these up, the ones that are below here, we should see that there's 11. So 11 scores that are below that 186. So I'd say 11 plus half of that 1 score that's 86 and divide that by 20. So really that's 11.5 divided by 20. So here's what it is as a decimal, right? Multiply by 100 or slide that decimal 2 spots to the right to make it a percent, and then round to the nearest percentile. So that would be about the 58th percentile. So what that calculation is doing, right, that 1 score that is 86, it's essentially splitting it up like that, and it's making half of it go to the below and half of it going to the above. That's what the calculation is doing right there. So we're saying that 58% of students who took this same English quiz got a score that was at or below a score of 86. Okay, and the next one here, same idea, same set of data actually, same English quiz, 20 students. Now I'm saying, how about if the score was an 84? So now I have multiple 84s right here. So I still need the amount that fall below the 84. So if I count those up quickly, there's 8 scores that are below the 84, right? There's 2 scores that are 84. So I say 8 plus half of the 2 scores that are equal to 84, divided by 20. So really I have 9 divided by 20, so 0.45 or 45%. So same thing with that calculation. It's really just splitting it up so that half of it goes to the below and half of it goes to the above. Either way, we get the 45th percentile. Okay, 2 more examples, then we're done. All right, we got Jason. Jason graduates 25th out of a class of 150 students. Find his percentile rank. So I like to think of it like this, right? We have students who are ranked 1 through 24, right? These are the ones who are ranked higher. They're above Jason. Jason right here is at position 25. Here's Jason. And then anyone ranked 26 through 150 is really below Jason. Okay, so how many are below him? If I take that 150 and I subtract Jason and everyone above him, subtract the 25, there's 125 students who are Jason or above. So that means here, that's the 25 that are Jason and above. So 150 minus those 25 students, we have 125 who are below. All right, so the 125 that are below plus half of the 1 Jason, and then divide that by 150. Okay, so that's going to get me as a decimal 0.8367 or 83.67%. So decimal, I usually pull it to 4 spots and then make it a percentage to 2 spots. That's saying that Jason is at about the 84th percentile. All right, last one. So here we're looking at Avon representatives. We're saying there's 6,000. That's just a makeup brand in America. Sarah outsells 2,500 of them. What is her percentile rank? So we're given the below because we're told that Sarah outsells 2,500 of them. So there's 2,500 that are below Sarah that she outperforms, plus half of the 1 Sarah, divided by the 6,000 total Avon representatives. So here as a decimal, I get 0.4168. Then as a percent, that becomes 41.68%, right? Either multiplying by 100 or moving that decimal 2 spots to the right. And then we round to the nearest percentile. So 42nd percentile. So essentially, Sarah outperforms about 42% of her fellow Avon representatives in the United States. All right, have a good rest of your day.